Hi, good morning. My name is Ahmad Shafiq bin Ahmad Flusi. My matrix number CE20011. So today I will present about our project for electronic circuit analysis and design. So we have only two members, which is me and Ko Wing Kang. So today I will present the introduction, importance, and calculation for our simulation, manual calculation. So today I will present firstly I will present the introduction. So we have given the active filter specification, which is the mid gain is 12 dB and low cutoff is 20 kHz and high cutoff is 70 kHz. So today the band pass filter has two cutoff frequency, which is high pass filter and low pass filter. In this project, our group does to develop the simulate 6 order band pass filter and by using operation amplifier op-amp. So the next slide, which is importance of active filter in electronic system and relate it to the current technology trend. So this some point for the important the active filter. So firstly, this filter are more responsibility than passive filter. They have no resonance issue. Also, you can use active filter for voltage regulation and use for reactive power compensation. Active filter also have using op-amp does not load the input load. So on this active filter, they have 4 types. The input current technology relate on this current technology, which is the Butterworth, CBCs, Bessel, and elliptical filter. So next, the manual calculation. So you can see, I zoom in. We are giving the active filter specification. This. So from our calculation, we using high pass filter and low pass filter. On each high pass filter and low pass filter, using 3 types, which is high pass filter 1 until 3 and low pass filter 1 until 3. See, this is the formula for high pass filter. We calculate all and we having the answer, which is resistance frequency 1 until frequency 3. This one. So when we have the 3 answer, we also have the current for each high pass filter. In this is the answer: current 1, current 2, and current 3. So next, we using low pass filter. It's the same thing in high pass filter on three step. So this is the formula for low pass filter. And this the answer, resistance frequency number 4, number 5, and number 6. And also we get the answer for the current for low pass filter. Here current 4, current 5, and current 6. So lastly, we using the amplitude amplifier. We combine all the current from high pass filter and low pass filter from each method. So this is the current 1 until current 7. So this we want to find the current 7. So this is the answer for high pass filter and low pass filter current here, and here's the answer for current 7. When we get the answer, we calculate with using this formula and this formula, and also we get the assume that resistance 4.7 kilo ohm. So this all the calculation for the manual. So next I will pass for the core for present about our simulation. So that's all. Thank you.
Good day, doctor. My name is Corwin Khan, Metric CE 2000871. Now I'm going to explain about our simulation circuit by using the Rotel software. So now we can see that this is our 6th order band pass active filter. So let's see the simulation result. So this is our simulation result, which is the gain in ratio in y-axis. So for this graph, we have labeled the data on the graph. So we can see that the low cutoff frequency is 22.13 kHz and high cutoff frequency is 67.4 kHz. In order to get these two cutoff frequency, first we need to get the mid gain in ratio divided by square root 2 in order to get the value of root mean square of for the mid gain, so which is 3.659, and then the bandwidth is 45.27 kHz, which is the FH minus by FL, which is our low cutoff frequency. So for the table 5.1, this is the comparison between the specification given and also the manual calculation simulation result here. So we can see that the mid gain A is 12 decibel, which is the specification given. In our simulation result is 14.3 dB. We need to convert since this is the value in ratio. So we use 20 log 5.22 to get the mid gain in dB. For the low cutoff and high cutoff, they are slightly close with the value, and the bandwidth value is 48 kHz. For our simulation result is 45.27 kHz. Regarding the center frequency, we get 38.72 kHz, and the manual calculation is 39.24 kHz. And lastly, this is our quality factor, which is 0.8175, and in simulation result we get 0.8531. Next, this is the simulation result in which the Y skew in dB. So in this graph, we can see that there is a slope on the left hand side and the slope on the right hand side. So for the left hand side, we get the slope is 60 dB per decade, and for the right hand side is which is a slope negative 120 dB per decade. So in here we can see that there is a remain, which is minus 200 dB. So we get the Y2 as negative 200 dB in order to get the simulation result for the slope. After that, this is our calculation for the row of rate for the first third order, which is the left hand side. So we get 60 dB per decade. So based on the graph given, which including the y2, y1 and x2, x1, we get the slope is equal to 66.67 dB per decade, which is slightly close with this calculation, which is 60 dB per decade. And then for the sixth order, which is right hand side here, so we can see that this is the slope is equal to negative 120 dB per decade. And here we can see that we get the value from based on the graph, which is y2, y1, x2 and x1. So we get the value is equal to 135 dB in negative. In conclusion, we are able to calculate the bandpass active filter by using the certain formula in order to obtain the component value that we need to fulfill our 6th order bandpass active filter circuit based on the specification given. And we also able to build the circuit by using simulation software, which is Proteus, in order to verify the circuit is functioning according to the specification given, such as a mid-gain or certain high or low pass cut-off frequency and so on. That's all from me. Thank you.